Permutations are a part of statistics where we're looking at arrangements of objects, and a perfect way we can think about it is a lock. We know that the order that we arrange the numbers in determines whether we unlock the lock or we don't. So the order is the most important part of the arrangement. So that is what a permutation is. It's an arrangement of objects where the order that we arrange them in is of vital importance for us. Now, so let's take an example. Say we have the numbers 1, 2, 3, and 4. Well, we can arrange these numbers in a lot of different ways. So I like to do organizing groups of them. So my first grouping is, what if I put all my ones in the first place? Well, what are the other ways we can arrange those numbers? So we can have 1, 2, 3 and 1, 2, 4. Those are two different arrangements. And we can go through and we can do all of our different arrangements, and we can see in the end there were 24 different ways that I could actually arrange these four numbers here. Well, when we go to do that, of course it takes a long time to actually do the arrangement themselves. And so mathematically, we want to know, is there a way that we can actually solve that problem without having to actually write out all the arrangements? And that's exactly what a permutation is. It's a mathematical equation that we can use in order to figure out how many total possible arrangements we have given a certain number of objects. The way that we do this is whatever your first number of options we have. So we have 4 options. That's our first number. Once we've used our 4 options, remember one of the numbers has disappeared. We already used it. For example, we already used 1. So the second set in my numbers that I can use, I would only have 3 options left. So if I started with 1, 2, 3, 4 and one number dropped off, then I have 2, 3, 4 left. My next set of options, now I have 2 numbers that dropped off, so now I have only 3 and 4 left that I can choose from. And my last set of options is just a single number I have left. I only have the number 4. So you can see that we're dropping off the number of numbers that we're actually using. So in order to calculate the number of arrangements, we just multiply 4 times 3 times 2 times 1. And notice it gave us the same number. So it's a lot quicker if we're going to use the permutation to solve it rather than doing our organized list for that. Now, this actually introduces us to a new math symbol, and that's called the factorial. And so sometimes you're going to see a number and then it has what looks like an exclamation point after it. Well, that exclamation point, we always say factorial. So I would say 5 factorial. What a factorial does is it does the calculation of a permutation. So it takes this idea of taking your number of objects and reducing one each time in order to solve the number of arrangements. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Now notice we never include 0, because if you included 0, then suddenly your answer would always be 0. So don't include 0, you only stop at 1. 4 factorial would mean, in order to find the number of possible arrangements, we would multiply 4 times 3 times 2 times 1. 3 factorial would be 3 times 2 times 1. 2 factorial would be 2 times 1. 1 factorial would just be 1. Now, our factorials get big very, very quickly. If I actually found 25 factorial, this would be the number of arrangements I would actually have. And 25 is a relatively small number. You can imagine what happens when we go to larger numbers. Now, when we go to apply this, the way we apply this is sometimes we don't want to use all our options. So say I have 7 posters that I've purchased, but I only have 4 walls in my bedroom, and I only want to put 1 poster per wall. I want to know how many different options I have of arranging those posters. Well, we use kind of a new equation to do this. And what it has is it has a small n, has a large P, which means permutation, and it has a small r. So what do those letters mean? Well, the n is the total number of objects that I have to choose from. So in this example, I have 7 posters to choose from. The R is the number that I'm actually going to choose, or the number that I want. And in this example, I want to use 4 posters. So I would write this as 7P P4. Now, what does that mean? Well, it creates an equation for us. And the way that this works is the total number of options, or that n, goes on top as 7 factorial. And we know that factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's like we're creating this fraction or a ratio. Now, the 4 comes in on the bottom, and that is 7 minus 4 factorial. Well, if I do 7 minus 4, I get 3. Therefore, it's 3 factorial. So I do 3 times 2 times 1. Now, notice this is like a fraction here. And I can actually go and I can cancel out 3 divided by 3 because that equals 1. And I can cancel out 2 divided by 2 because that equals 1. And I can cancel out 1 divided by 1 because that equals 1. So it means the only numbers I'm going to multiply are 7 times 6 times 5 times 4. And that actually equals 840. That means I have 840 ways that I could arrange those 7 posters if I only chose 4 of those posters. It seems mind-boggling for that. Now, I can also find probability with that because I only have one room and there's only going to be one way that I choose to arrange those posters. Therefore, my probability of choosing the exact way I want to arrange it would be 1 out of the 840 possibilities. So permutations take us into a world of predicting how many arrangements we can have for a certain number of objects. Now, going back to this lock, you can tell how effective it would be, because out of this lock, if I have 40 numbers, which I do, and I only want to choose 3 out of those, imagine the number of arrangement possibilities I have. So today you're working with permutations. I know you'll do well. Good luck.